Good morning, everyone, and welcome. My name is Paul Briscoe from Tag Video Systems, and I'd like to welcome you to our webinar. We're going to be talking today about Playout, particularly Playout in the cloud, and things related to that. And I'm pleased to be joined today by an old and very good friend of mine, Mr. Peter Wharton,
Great to be
who
here.
is working
Thanks,
with Tag. Oh, I'm not done with your intro yet.
Paul. Okay.
Peter's well. If anybody on here doesn't know Peter, you do now. Peter's been around the industry a very long time, as have I, but he's far better known and far smarter and far more connected. And we're really happy to have him on board here at TAG. We have a bit of history of our own, and we're wearing a couple of shirts to reflect that history. Peter, maybe you want to tell the story around why we're wearing these shirts.
Well, I've been producing a technology conference for SMPTE for almost 20 years, or 20 years now, with a few years off, it's called Bits by the Bay these days. And several years ago, I invited several of the major vendors to come and do presentations on 2110. And what I usually do in that conference is to try to weave all their conversations into a single narrative. So you build from a basics to a very detailed understanding by the end of the day. And in getting all these vendors to do this, I was very concerned because, these are competitors and how they would do this. So I wore a referee shirt to it and a referee hat and had a whistle. I was ready to keep them from fighting. But instead, what we got was all the vendors came together and actually worked off a single deck and handed the baton and did one presentation on the evolution of 2110 for the audience, which was beautiful to see. It's great to see the collaboration in our industry. So out of that, everybody got tie-dye shirts who participated as a kumbaya for all coming together and doing this.
And you were the peacemaker. Yeah, it worked out really, really well.
Well, I think you all did the piece. I was just glad to be there and try to hammer it together, but it didn't need any hammering, it turned out.
There you go. Well, yeah, no, when we saw you in the referee shirt, we quickly huddled and said, well, we better look like we're agreeing here just to upset Peter. But in actual fact, what you captured there was the convergence of thinking around SMPTE 2110, because that was at the point where we were all pretty much agreeing, and look where we are today. Anyway, let's get into this. Let's talk a little bit about Playout, Peter.
Sure.
So cloud-based Playout, people build big master controls and server rooms and things to play out their content, and more people have been moving some of that to the cloud. And now with COVID, of course, nobody can go into the office and everybody's thinking about cloud. So what are the drivers that drive a customer to looking at and planning cloud-based Playout?
So I think as engineers, our first instinct is to think this is a technical solution and that we look at how the technology works and make it work. But we have to step back. It's really a business decision. It's about letting organizations plan effectively for the future. And so let me just tell you a little story. I mean, I hope you can see this picture. This is CBS Television City's front, this beautiful Art Deco entrance in LA. And if you go into the lobby, if you're a guest there, in that lobby, there's, it looks like any other dentist lobby, but there's this coffee table. And in the center of this coffee table, there's a piece of equipment. And that piece of equipment was actually the first master control switcher ever built. It was hand built by CBS employees in 1961. Pretty cool,
That's
right?
Fantastic.
Yeah, I mean, and it shows the innovation and the kind of mad scientists that our industry really fomented from the beginning. I mean, you go back all the way to Zaworkin and Farnsworth and Armstrong. I mean, this is the sort of, people that were drawn to the industry and loved to do. And I, in fact, did a lot of ham design and building of my own equipment. I worked for ABC Networks back in the 80s. I had that same mentality. And what's interesting about this master control switcher, because that's what we're talking about is Playout, and this is the heart of a Playout system, this was built by CBS in 1961. And stayed on the air, essentially unmodified until, and I wish we had a poll here we could have people guess, because I'd love to have people guess at this. It stayed on the air until 2003. 42 years. This was the master control switcher for CBS in LA. And with no vendor support, no vendor or anything, this is all homebrewed, and the people who probably built it didn't work there anymore. It's really amazing when you think about that. But that's the legacy of the broadcast side of industry, which is certainly different than the OTT side. And so I think the times have changed. We are now working really in an era of uncertainty where it's really hard to predict the future. And so to think that a piece of gear will last 10 years, much less 42 years, is a challenge. And I point out, like, here's a friend of mine, Thomas Edwards. Many of us know in the industry. He's a great guy. We were talking about 2110 earlier. He was a huge proponent of 2110 early on and really helped do a lot of the work. And I asked him one time at a conference, where will you be in 5 years? What will you be doing? He says, anyone who can tell you where the media industry will be in 5 years is a liar. And I think if you look at the equipment we build today and the fact that you have to take 2 to 3 years to plan, build, deploy, and get something up and running sometimes, and then you want to have a 7-year monetization, and we don't know where we're going to be in 5 years, that's a really hard equation. And in this particular case, here he is working for Fox, and 6 months later, whatever he's building is in planning is throw out the window because now he's working for Disney because they changed hands, and now they're mashing everything together. So I mean, even that tells you he couldn't even see 6 months into the future when he did that. So I like what John Honeycutt at the same conference also said, which he said, infrastructure used to be an asset, and now it's a liability. Because if you don't know where you're going, how will you really get there? And so I think that was really one of the key things I saw. And I helped build John Honeycutt the Discovery facility back in 2005, and we tried to do it as much with software and I actually designed some new products from scratch for that, to help do graphics and things. And we really thought we were building capability for the future, but none of us saw that in the very next year after we launched that facility, that the iPhone would be released, that Facebook would go from being a private to a public service, and that Amazon would launch its first instance in the cloud, and that Netflix would also stream its first stream, all in the next 12 months after we launched that facility. And that was, looking back on an incredibly rapid change, and yet the rate of change is even faster today. So I think that's the challenge.
Absolutely. So I mean, there's huge uncertainty. Obviously, you and I come from an era when you could actually plan, the depreciation life of a system you built. So in the past, we would accommodate uncertainty by overbuilding. We would accommodate uncertainty by planning for expansion, leaving space in the racks, at extra empty racks. You built a private data center in today's technologies. So how does cloud open the door to doing things differently, and how does it improve on these legacy models for planning for the future?
Well, even if you plan for expansion, even if you build software-based facilities so they're more adaptable, even if you do a data center model, right, you're still spending a lot of money to build a physical infrastructure, assuming you even know what kinds of capacity you need to support in the future, and still overbuilding or unfortunately underbuilding and not being ready. And so the move to the cloud really allows media companies to shift their spending from capex to opex. So that's really key, because it means that they're not having any sunk costs in infrastructure that will be obsolete even before it's commissioned. And it also helps them avoid making long-term business decisions and investments when they really don't have a good handle on what the long-term looks like. I mean, take a look at, in the US, we have these things called virtual MPVDs, which is basically cable provider, kind of like cable providers, but they're going over public internet and to, the streaming set-top box type things. And none of them are making money. A year and a half ago, they were the big thing, and everybody had to invest to be able to support those as broadcasters and stuff and send streams to them. But it turns out that, even the best of them, aren't making money. They were $30 a month, a year ago, and people were cord cutting to move to that. Now they're $65 a month, and the attraction is much less. And even at $65 a month, they're paying $61 a month in fees to content providers, so they're not making any money. So it's a big challenge, going forward, because we don't really know what the business is going to look like 2 years from now, much less 5. So if you go to a public cloud, you really have the kind of flexibility to scale up and down on demand, adapt to changing business needs. And what's also really key is you can tie your actual costs of processing and consumption back to the content and back to the channel, and put real cost metrics to work, which either enables long tail content with low margins, things like your archives, or proves that that's not an economical business model. Because in the past, you were also buying something and never really allocating how much time was used by somebody. If a transcoder only got used one day this week for one show, are you really going to bill them for the entire week's worth of ownership of it? So now we have a different business model where you're really paying for what you use. And unlike a private data center, where even if you build a big private data center to do this, it has to be monetized even when there's no workload running on it. So it really enables, as I said, a business decision to move forward.
The demand-based aspect of that flexibility is a huge strength. And, provided we can get all the capabilities we need in the public cloud, it becomes a really compelling solution. So talk a little about the other side for a second, and that's OTT. That's people who started life in OTT. They never were broadcasters. They're simply a great big cloud library with subscriptions. They're all cloud-based, right? Don't they need to be in the cloud anyway?
Well, yeah. So you would expect anybody who's a digital first or a digital native channel and content provider to be based in the cloud from the get-go. And that's what we're seeing. And in the early stages of cloud software and cloud's capabilities, the real focus was on low cost. It was really keep minimizing those costs because these were long tail content from the beginning in small markets. So you had to meet those demands of a highly fractionalized and targeted audience to make that work. But it also meant you had to support things like targeted advertising and server-side ad insertion stuff in the beginning. So the world of OTT playout and delivery developed very differently than the traditional playout, with a different level of resiliency and reliability, but also a whole different set of features. But what was really important was because of this low cost and because of this consumption-based model and low capex, it really reduced the barriers to entry that allowed small OTT providers to actually launch their channels.
Yeah, and look what's happened to the small side of that statement, right?
Right, exactly.
It's turned into something that I don't think any broadcaster or any human, for that matter, ever really foresaw, which is, of course, a wonderful watershed. So back to broadcasters, back to TV stations, people that run 24/7, scheduled content. Does the cloud make sense for their application as well?
Well, that's a really good question. And for many years, I've heard television station engineer directors and such tell me that the cloud doesn't make any sense because, after all, if you look at the way a TV station works, the transmission site's usually co-located or with an SDL right next to the station. It goes to the TV sets that consumers have. They're getting feeds directly from satellite. So sending content all the way up to the cloud to bring it back down again and just to put their playout in the cloud doesn't make any sense, right? And so that's been the traditional discussion, that this did not make sense for TV stations, primarily because the economics weren't there. But the business model is changing. Now you have very large station groups where they have to manage the technology stack across a large number of stations and really want to do it in concert, not everyone be piecemeal on different platforms and different things at different times. That gets very hard to manage. I mean, there's some station groups with over 100 stations and hundreds of channels. And so, they're really basically the same as any other major cable company or anything else in that regards. And they're also seeing that they're doing more and more on OTT platforms. They have their own OTT platforms and are doing things like that. So maybe that's really the future of a station. It's really that the antenna for terrestrial broadcasting just becomes another output of your cloud playout, and that the station becomes a contribution and management point, but you bring the content as much as possible directly into there. So we're seeing that. And we also saw where, because we had these two different platforms, it made the quality different, it made the workflows different, it made managing content different, it made it much harder to run a station and a station group. But if we can unify and have a single platform for any kind of delivery and any workflow in front of it, then we really simplify operations and make it much easier for stations to have the agility they need to take on new content, new programming, and new channels and such. So that's what we're really seeing here. The other neat thing about this is, if you're running in the cloud, then by default, every operator is running a remote console from the system, right? So in the current pandemic, stations have realized something, that can't have people working in the station, that running in the cloud, those who already went there and those who are going there now realize there's a huge advantage in that, because they can run their station from anywhere. And that really creates a lot of opportunity for them.
For sure, it does.
And makes things work.
Now you slipped a little term in there, which I just want to touch on because I think it's an important one. You talked about them running the same technology stack in more than one place, and that's thinking that is aligned sort of with this new world we're talking about. In the past, we never thought about technology stacks quite so much as interfaces. I'll send you this kind of a signal. Oh, I can receive that. And technology stack is now becoming much more important because things are not as simple as a video on a coax. So that's an interesting observation you made. So if we find people are building these cloud-based playout systems, for live and scheduled programming, traditional broadcast, and so they get the flexibility, they get the scalability, they move to opex on-demand models, of course, of interest to us. How does this impact monitoring and the monitoring system?
Well, I think first off, the monitoring system has to fit into all this, and therefore needs to be cloud-based, because you're not going to bring all the signals down to the ground to monitor. You need to monitor them at the source, to make sure the source is good, and also various distribution points in that cloud, so that if there are impairments, you know exactly where they occur. And because you're paying for every egress fee of streaming, you don't necessarily want to stream all those individual feeds back to a home place outside of the cloud and pay for that. You'd rather capture them up there and stream just a single mosaic to make it more economical. And the other thing is, as you're moving to the cloud, stations are doing this because they want the ability to scale up and down, whether that's for sporting events or whether that's just simply because they want to launch and test drive new channels or do different things. So the monitoring system has to scale accordingly, and it has to mirror the underlying workflows and consumptions. So I think, that's what we're really seeing, and you come to things, something like March Madness or Olympics, where you need to scale up rapidly to support a large number of events and then scale back down. The monitoring system has to work in the same model and be able to scale back to really almost nothing during the quiet hours, and with a commensurate savings and costs. And so I think that's key.
So how does this differ? I mean, are we not just running the same monitoring system in the cloud, or is it somehow different? What's the impact on the monitoring system and the customer's use of that?
Well, the first thing to realize is that when you take something that exists and move to the cloud, it has to work in the cloud, right? And so working in the cloud, the first thing is it can't have any hardware dependencies. So first, it has to be fully software. A hardware-based multiviewer is not going to work very well in the cloud. You can't ship it to Amazon and have them installed in a rack for you. And then it also, even if in software, in virtual machine worlds, we've done things like use multicast for discovery and registration and other things about a system, how a system might work. Well, multicast is not generally supported in clouds or in internet at all. There's a little bit of it happening right now, but it's only in one small area, and it's really an interesting development. But you really don't want to have a system that needs multicast, because that won't work. The other thing is the licensing model. It can't require USB keys, right? Because we can't send a USB key to Amazon and have them plug it in for us. And you really don't want to be dependent on a USB key sitting in your station when the internet connection goes down. And obviously, it won't support SDI. And then, okay, so now we have a multiviewer running in the cloud, but now we need to support the full range of requirements for what the cloud really does and what the delivery platforms. That means that in addition to traditional transport stream monitoring and probing, we also have to support things like HLS and common cloud formats, both on the input sides and on the output sides. So we want to be able to, like, for example, send that mosaic to us, the output of a multiviewer, as an HLS to be able to monitor, or as a transport stream. We want that kind of capability. We also need to be able to monitor streaming feeds. So we need to monitor things like ABR content and metadata, and be able to get into the CDN distribution points and behind that secure zone and authenticate, so we can monitor in all those places in the workflow. And of course, as we move to the cloud, we're also seeing a greater uptick in the use of UHD, because broadcasters are not necessarily adopting UHD yet, because of the consumption of bandwidth that's scarce to them. But in the cloud, we're seeing a lot more uptick on UHD, so we need to monitor well that supports that, or multiviewer. Finally, I think just like customers are now building unified workflows, a multiviewer needs, and a monitoring system needs to treat all platforms as equals. Customers don't differentiate. So we need to also help them and provide assurance that the quality is the same across all of their distribution platforms, because the viewers aren't seeing that, don't make a difference. They don't care whether they're watching OTT or broadcast or your private platform or whatever else. If the quality is not there, the quality is not there for them, and they're not going to understand, oh, well, that's a different way you're getting it to me. And finally, you get into the cloud and you run into a whole new set of issues and problems. One of the biggest things I've run into is jitter. The cloud public networks like Amazon are built just the same as a public internet, which means between any two servers in that cloud, you can experience significant jitter, just like you're going through a public switch network. So we need to be able to measure the performance of these networks, monitor the jitter, monitor it for out of order packets and other transport errors, and be able to analyze those and alarm on those and know when we're hitting thresholds we can't recover from. And we need to support the technologies that actually address those problems and make the cloud work for us. So when we try to make the cloud work, we use this thing called ARQ, which has been around for 20 years, surprisingly, which resends bad packets and lost packets. And that's the fundamentals of what RIST and SRT and ZXC use. And so we need to have a cloud monitoring system that actually supports those transport solutions so that we can actually monitor those signals in their native format.
Boy.
Yeah, I mean, so a lot of things.
That's a handful.
Well, and even it keeps on going. The list never stops. You're also having to like tie it into a monitoring system so that it actually informs your redundant playout systems so they know which one's working well. And lastly of all, it has to be economical. You can't have a monitoring system that's more expensive than the playout system you're monitoring.
Well, so hold that last thought a second. But I mean, just to recap on this, it's a handful in the cloud. You go from a place where you're monitoring an SDI, a bunch of SDI feeds, to suddenly we're monitoring multiple formats in some place off premises with a network that we can't fully groom. Yikes! So I mean, it's great that we do all this stuff in our product. And it's interesting to discover, as I have as well, that people are interested in different things in terms of quality of service in the cloud than they would be in a ground-based network system. But boy, it's a handful. So back to your last point of economical. So this is very complicated. This is very involved. How do you make it economical? What does that look like?
So obviously the economics have to work, especially because part of what the cloud is supposed to do is help you be able to monetize long tail content and archives and such. So there has to be that, it has to work there. And many of the early cloud playout migration projects are costing those media companies far more than building even an oversized on-premise replacement might have cost them, and haven't really realized the economic benefits. And I can show you some examples. I mean, this is actually real world costing for two different playout systems running exactly the same workflow in Amazon, and these are just the raw Amazon costs. And as you can see, the red one, which is a cloud native, cloud optimized playout system, costs about 1/8 of the cost of a traditional playout system that's basically what we call lift and shift, where they basically make it work in the cloud, but it hasn't been rewritten from the ground up to be optimized. So you can see there's a huge difference, and this is real world costs. This is when I was doing some POCs for a customer and standing up and measuring those costs every week and looking at what those costs were. And I saw several vendors. Most vendors were like that blue one. It's not one vendor in particular. Almost all the traditional vendors were there, and it turned out there was one who was written their code from the beginning to run in the cloud with a focus on economics. That was the red one, and I think that's a really important thing to see. Because there are ways you can save that, and I think we can probably save that for another call, or maybe some questions if some people want to how those economies are realized. But it's how you leverage the cloud and use the different services in the cloud to actually run your workloads versus just throwing it all up there in a big server and letting it run all the time. But part of it is being able to scale up and down to mirror the required workflows and monitoring points in a monitoring system versus leaving something running all the time. You're looking for a system that can be provisioned through an open API that allows the media company's orchestration system, because you really want an orchestration system that's managing all this, that's saying, this is the workload I need to run right now. These are the number of channels. This is what I want to monitor. This is what I need to do. That can actually automate all of the multiviewer, the monitoring system that's running, so they're only running the parts that we need to run when we need to run them. And also, that same intelligence also allows you to squelch alarms on signals not currently active and good night systems that are no longer needed when the events are over. Your monitoring system needs to right size itself based on load being provisioned, so that you're only running on the right size server to save costs. But I think one of the last things and key things is, if you're going to have a system that's scaling up and down on demand and running in the right size service and all those things, it needs a licensing model that supports that kind of consumption-based usage. So you don't have a licensing model that says, I'm buying 1,000 monitoring points and I'm paying for them persistently. I'm actually paying for how many monitoring points I'm using at a given moment. And so basically a meter is running and I'm paying for the actual consumption. And that's where you really can get to realizing economics. And that's actually the heart of what's behind TAG's zero friction solution.
So your slide, which you have on the screen, is a really interesting one from a couple of points of view. One is obviously just the difference in operating cost. And this doesn't even consider scalability necessarily, right? So that operating cost
is just one set of channels running, yes.
Right.
Yeah.
So if you're good night overnight, then that gets even smaller, right? So that's right. Really, really compelling. At the same time, it's also pretty compelling when we see people building dynamic systems where instances of complicated functionality and production value are spun up and spun down. The ability of the monitoring system to adapt and keep the smallest possible footprint, yet provide all of the functionality required, is a key part of maintaining that. So this is a really compelling graph for me.
Oh, so I can go back to it for a second. There we go. Okay.
Yeah. No, that's okay. I'm done talking to it. It's a shocker. It slaps you in the face.
Yeah. I mean, when I first saw that, I was like, oh my gosh. Even I was surprised at that. Yeah.
Why does the lift and shift rise to the right?
As they started running more workflow through it. So as we started actually playing out, this was static. We weren't actually playing any playlists. And then we started playing out playlists and processing media for those playlists. So as we started actually implementing the channel, it started to bump up here, right? Because this was, we got it running. We can test the workload. Okay, it works. Okay. And now we're actually publishing and running playlists every day. And that's what caused it to bump up.
Interesting. Yet the same wasn't experienced by the native cloud stuff. Very interesting. There's a lot of second order artifacts of this transition that are interesting and exciting, and I think there's opportunity around every corner.
But if you look at this as a business decision, and trying to address uncertainties by not spending too much money and being, this shows that you really have to focus on how are you spending that money. And I think this has been, I've actually shown this to several vendors, and it's been an eye-opener for them that they've had to go back and rework what they're doing to really leverage this, that they didn't even realize that this was possible, the red bar, So it's been a real eye-opener.
Well, and that's been a moving target because it wasn't that long ago. There was no red bar, and that red bar's, going to get smaller. Bigger exposure and smaller impact over time. So to turn the light back on, focusing selfishly on ourselves for a minute, talk a little more about cloud monitoring and maybe wrap up your thoughts on how all this impacts monitoring in the cloud.
Sure. So the point of monitoring is to know what's going on in your system and to be able to analyze all the pieces and components and make sure that they're all performing as expected. And you wouldn't necessarily hire a fox to watch your hen house, unless you're a Looney Tunes cartoon, So the same thing is also true. A lot of times, because the complications of going to the cloud, there's a lot of push to have these large single vendor solutions to do it all. But then you don't really have anybody giving you that outside look and monitoring these things, or even showing you those graphics like we just showed with costing, because you've gone to a single vendor approach. I really think a monitoring system should have a level of independence from the other underlying components, both because it brings you that third-party observer position, and also because you don't have shared code and services that potentially means you're running the same codecs both on your playout system and on your monitoring system, and when one is bad, the other one's bad, or they conceal each other's errors, but other systems have different problems. You want that kind of mixed vendor system so you see interoperable issues.
Nothing like drinking your own Kool-Aid,
Right, exactly. The other thing is you go to the cloud because you want to be able to have this agility, not only to change your systems, but actually change different providers. You may decide you want one vendor for this workflow and a different vendor doing something similar for a different workflow because the cost structures are different and you need different capabilities. And so, you want something that we can easily bring in different vendors and substitute vendors or different services in the cloud. And that's one of the beauties of the cloud, is that ability to reach out and use all those variety of services that are available to you without building infrastructure. But if you're locked into, if you have that single vendor lock-in, then you don't have that vendor agility and the ability to do that kind of right sizing. So I think, again, it points to having a third-party monitoring system that is abstracted away from the suppliers of the actual workflow.
Yeah, certainly we believe in that. and it's been our customers' experience that having that independent third party is a useful way to ensure your confidence in your system. And I jokingly mentioned Kool-Aid, but when you do have a single vendor solution, that's all great as long as you don't have to interoperate. And if you do, you need to very carefully test all those edges. So this is a great strategy. And marrying that with the flexibility of cloud deployment and the flexibility of scalability and the flexibility of license, what's the word I want to use here? Agility. It makes, I think, a fairly compelling case for monitoring in the cloud. And of course, cloud and ground-based systems, at least ours, homogenize into one big system anyway. So we don't really care where the instance of monitoring or visualization is. It's on the ground. It's in the cloud. It's out there somewhere. And I think that's kind of the look of the new world. Peter, thank you for the conversation. This has been wonderfully informative, and I have seen some questions going by.
Yeah,
I think Cindy is going to jump in here and curate some of those questions for us, and I thank all the attendees for attending and for your questions. Cindy, what have we got in the queue?
Hey, so many great questions today. Good to see you.
Thanks.
All right, so one of the questions was around latency, and we had several people asking about latency, and specifically, what is latency? And routing through cloud introduces delay as it is unicast and a server and a public network, and just talk about more delay and latency.
So routing through the cloud doesn't necessarily introduce any more latency than routing through public internet or any other network. In the work I was doing, we had a 10 millisecond round trip latency to the Amazon region where we were running our workloads in. Granted, it was in probably 15 miles away, so that was a good reason why, or 20 miles away. But and you can get local zones and stuff. And in fact, you see the Fox is building a whole new Playout Center in Tempe, Arizona, and they're just across the street from the AWS locals region. So their latency is no more than it would be in a campus in that regard. So the cloud itself isn't the latency. The latency comes from compression, and it comes from transport processing like RIST and the other similar top technologies, because they all introduce buffers to allow time to resend packets. So that's where latency comes from. You can obviously have latency in compression that is subframe with JPEG 2000 and other kind of models like that. You can do uncompressed these days in one of the Amazon regions, which means you have basically subline latency, minus the 10 milliseconds, but and then the last latency would be in the multi-viewer itself for monitoring, where we're under 2 frames of latency there. So all in all, you can get it down to a handful of frames of latency, but it takes a lot of work. And you have to look at every single piece as you're putting the puzzle together and what kind of latency they introduce.
Right. There's another angle I'd like to throw in, and that has to do with video formats used in the cloud. So when we're on the ground and we're using TS, for example, we really only have to deal with encode and decode delays. The delays of going in and out of TS are very, very small. When we go to the cloud, we start looking at OTT distribution. And OTT uses different methods of transmission, typically involving chunks of essence. So a 10-second chunk of video and audio every 10 seconds is delivered to the player. This immediately requires that you have a 10-second latency, because you've got to build 10 seconds worth of video and audio to be able to send using this distribution method. So you can't blame the cloud for that latency. You can blame the format being used in the cloud because it's a cloud-centric format. So we have to be careful to separate out what are technological issues with the cloud versus what are actual choices and the outcome of those choices, such as picking a format.
Right.
Can I follow up with a related question, because I think it ties into what you're talking about there? We have a question saying, how long before an entire TV studio, routing, mixing, graphics, etc., could be in the cloud? And again, is that actually possible and real time with latency that would work for them?
Well, I don't want to be snarky. I'll never get the studio in the cloud because I can't get the talent to go up there or the cameras. But the control room, yes. And we're starting to see that happen. Clearly that's happening right now, that there is cloud-based remote live production being done. It is still in its infancy. you know, we've had REMI for a long time, which basically means we were running the hardware in a centralized location and bringing all the raw feeds back. Now we put that same applications into the cloud and just extend the control panels to that to the operator positions. This is going to be a place of significant investment in this industry in the next couple of years. You know, it was certainly amplified by the current pandemic in a huge way. But the work was already undergoing, and there are people today who are doing remote production constantly. I was talking to some colleagues at MTV who did a whole, event in the cloud as remote production and stuff. So we're seeing this happen. Absolutely.
Yeah, I want to mention too the latencies we're talking about here, because we're talking about playout and distribution in the cloud. The latencies in live production are very, very different. They're a lot lower, of course, and they're using somewhat different technologies in many cases to achieve that. So really what we've been talking about here isn't that relevant to latency in live production, where of course you want subframe latency wherever possible.
Yeah, I would agree with that. The latency in playout is different because you're willing to trade off more latency to reduce the costs and have better quality and bandwidth. And those are always the things. Those are always what you're trading off there.
Sure, and there's no production value trade-off in doing that. Whereas when you're switching a music show, for example, and you got to switch on the beat and things like that, latency from from the band to the finger on the switcher to the actual switch being taken to the visualization becomes ultimately super critical.
So related to what you're saying, we've got a question just saying, do you see the future as a ground cloud hybrid ecosystem, or do all technical facilities eventually go to the cloud?
But let me jump on Peter first on that one.
Sure,
I mean, it's always going to be ground cloud as long as there's humans on the ground. But how much of the equipment, how much of the resource moves to the cloud? I have a personal vision that someday it's all there, and you don't need a TV station. What do you think, Peter?
I think more and more you will see the workflow go from distribution and playout as close as it can to the camera being all in the cloud. And it allows organizations to put their operators wherever it's most convenient and economical. That, we've already proven, thanks to this COVID, they don't have to sit next to each other in the same control room in a live production. So we will continue to see this evolve, especially as the technologies become more mature and the costs get better aligned. Then it'll be a no-brainer. And I think, I see a number of organizations who are holding off on actually building physical facilities in that regards. I mean, Discovery was a perfect example. They moved their playout to the cloud starting in 2016. They wrapped it up, I guess, the end of last year. And now they have 400 channels or more running in the cloud of playout. It took them longer than they wanted, but they were running basically a 10 to 11-year-old system when they started this process that I'd put in there back in 2005, and it was 12 to 13 years old by the time they took it off air. That's an awfully long time, but they really looked at that and said, John Hike was like, I don't want to sit here and build another infrastructure-based system all over again, and really took the plunge and set the model here.
Yeah, it's brilliant. Yeah, I think more and more people are looking at that. So, I mean, in the short term, we'll see hybrid systems, obviously, as people move pieces to the cloud. But eventually, I think the economics, the flexibility, and just the general direction of the world is going to lead us to ending up with most things in the cloud.
The other thing is, if you build a hybrid, and hybrid means so many different things to so many different people. So, but if you're starting to build a cloud system for media, your goal is to build an end-to-end workflow as much as possible, because every time you take that piece of content out of the cloud, back down to the ground to work on it and send it back up to the cloud, you're introducing latency and costs, and you're introducing opportunity for failure. So, you kind of start at one end and keep moving your way backwards until it's fully end-to-end, but you don't want something where you're only operating pieces of the workflow in the cloud. That is not going to get you to the results you really want.
For sure. But for many people, that is the necessary safe route to get into the cloud from where they are today, and that's totally valid.
I meant unconnected pieces, whereas, sure. but
yeah, and that's why we build products that don't care where they live, in hardware or in the cloud. Just they're happy. Cindy, what else have we got?
Hey, we've got some more. Do Do you feel like the whole working from home, working remote thing is the new normal?
Well, I've been remote working from home for 20 years, so for me, it's the old normal. But and I think Paul may feel the same way to some degree. But I do think that this is definitely becoming the new normal because we're making it work. We're showing how it can work, and we're realizing the benefits of it. And the longer we do it, the more we're improving on the processes and the benefits. And a lot of people I talk to aren't looking forward to going back and commuting every day into an office to sit at a desk and do the same work they're doing from home. And to the extent that you can actually, have people work at different hours and not have, it used to be you'd use a control room for an event, and use an hour a day and it'd be down. And now you really, because people can work from home and do these things or play out, they can work at the hours that are best for them and do more work with less effort and less time. So I think it will become the new norm to a large degree.
Yeah, my answer is even easier. It's yes.
I like it. Here's a great question. Are any stations using tag as a separate program guide channel?
Stumped me. Peter?
Might have to circle back to you on that. We do have a couple questions. Circle back.
Yeah, please capture that.
I'm curious, whoever answered the question might be able to respond back, but I mean, like, so that we take the mosaic and we use it as a channel in error so you can see all the different things that are playing out. You could, absolutely. You could use it as a, instead of having like the Netflix or Prime Video, thumbnail views of all these things, they could all be active tiles that you actually put in a mosaic and give to your viewers. I don't know anybody doing that, but it's a cool idea.
Okay, the person who asked the question, I believe, circled back and said, yeah, it's an IPTV solution.
Oh, yeah, yes.
There's
simple yes.
Go ahead.
Simple yes.
And yes, but there's another way people are using it because not only can it be used as an IPTV solution, but because all the outputs can be encoded, people are taking all the inputs into their multiviewer. They also need to go to an IPTV and using multiple outputs off the same tag multiviewer as the encoded sources for their IPTV system. So instead of putting in separate encoders. So it's become a very economical IPTV head-end encoder for some. Yeah.
Nice. Can we come back to Jitter? Because that's such a good topic, and you talked about that quite a bit. So a couple things on Jitter. With all the Jitter in the cloud environments, would a real-time playout fully cloud-based system technically work? And there was someone who came back and commented about co-located devices where the transmitter shows a clean signal and the receiver records a constant yet periodic jitter errors. I'll turn that over to you guys.
So we're getting in the weeds on Jitter. Okay.
Well, maybe I'll take the first half and Peter can take the second half. So, Jitter is accommodated, assuming no packet loss, Jitter is accommodated through latency. That is, if we have a large amount of packet jitter, all we need is buffering to accommodate that amount of jitter. So we can go ahead and do this in the cloud, certainly for playout. It simply means that your playout would have to roll early by the amount of buffer you expect for your dejittering process in that particular transport format. And this is sort of the challenge with live, of course, we got to minimize it at every step of the way. We were talking about buffers that are, not frames. So, and frames of jitter is a bad thing anyway, but the applications differ wildly, but also the performance in the cloud can vary. Also, depending what you're using for transport, if you're using an ARQ technology where you have to have retries and retransmissions, you need much more buffer anyway to begin with. If you're using something that's like UDP streaming, you can groom that a little bit more, but you have to guarantee delivery in the network. So a lot of this will come down to what you buy in terms of performance on your SLA with the cloud providers. And actually jitter for video is something that they're wrapping their brains around now. Not distribution video, but live video, where the jitter criteria are very, very tight.
So, I mean, there are things you can do to improve the network performance in the cloud, but, in the case of the cloud, I've done most of my work, and I'm not going to say who because I don't think there's any reason that they're all different, but the cloud network is architected the same as the public internet, which means it's just switches interconnecting a fabric. And you don't even know, just because you're in the same availability zone, that you're actually servers in the same building on the same switches by any stretch. So we have seen significant variation in jitter between two servers running in the same availability zone in the cloud. And that jitter is not a constant. So you do need to plan for jitter and put these buffers in. The other place you get jitter in the cloud, besides the fact that it's basically a public switch network that is not over provisioned like a 2110 network would be, is that you also get jitter in the servers themselves. And that's because you are usually running in a virtual machine where you're sharing part of that server with some other workload you don't know about from somebody else. And every now and then you'll see a big spike in jitter, and it's probably because something else is stealing CPU cycles in an aggressive way and getting, and for a very small period of time, you might get a couple of hits of jitter. And so you have to, that's part of what you do a long-term analysis for and build for. There are ways around that. You can, go everything from bare metal to, having the entire server to yourself and other things. But again, they then impair your ability to scale and add to costs. So at some point, just understanding the jitter is a fact of life and addressing it is the best way to deal with it, because it will, even if you fix it here and there, it's a bit of a whack-a-mole. It'll probably show up somewhere else.
And it's also, as Peter notes, a statistical problem potentially, so you have to be very careful in your testing that you look long and hard enough to be sure you don't have any of these outliers that will take out the winning catch in the Super Bowl, for 5 frames because it was statistically that instant in time.
Right.
We do have a capex, opex question, and the question is, do you have an idea of capex versus opex? For example, yearly deprecation of station capex versus yearly opex for the same system in the cloud. I think they were talking about your chart that you had up.
Yeah, so when I've done this work for customers, I basically run a 3 and 5 year total cost of ownership analysis against an on-premise system and against different systems we're evaluating to see what those costs look like. So I can tell you that based on, if you're really running an economical system like the one in the chart that was economical looking, the red one here, it'll be very cost competitive to building that same workload as like in on-premise servers, for full-time work. The blue one, not so much. But it basically, the spreadsheet you end up building to do the cost analysis running in the cloud and do this analysis is fairly massive. And it's not like there's a one-size-fits-all, because even some of the vendors still have pricing that requires you to buy the licenses versus rent, subscribe to the services. And so, how you measure that and over how many years, and then you have to figure out their maintenance and support costs as well, and other things. It's one of the most challenging things is to define the economics of a project like this up front.
2 more questions, and then we are going to wrap it up. For anybody, if we didn't make it to your questions, we will circle back with you afterward. And a couple people asked about a trial, a demo. We won't be doing that during this session, but we would love to do that with you. One, just fill out the form and or let us know in the chat, and we'll take care of it. So the first question is challenges of distributing live content over OTT as compared to conventional distribution.
I think the main challenge of distributing live content over OTT is dealing with latencies, because OTT distribution inherently has high latencies. HLS typically has a 30-second latency minimum, and then you get more and more. So I think that is one of the challenges here, is how do you address those latencies? And if it's live content where someone's watching the game on a broadcast TV in one room and someone's watching it on a web streamed OTT version in another room, or maybe even 2 different OTT platforms or 2 different players, they could all see very different latencies. There are low latency technologies out there like CMAF and such that really can reduce latency and go even further. Again, it's all about what you're willing to spend versus what you're willing to put up with, because you can spend ways to reduce those latencies. And again, this also requires a really good network to support lowering those latencies.
And to wrap up here with questions, this is a two-part question. What's with the tie and 2020 Bits by the Bay?
Sure. Okay. So I thought we did a tie-dye at the top. We actually explained that we had a Bits by the Bay several years ago. We had a 2110 session and got all the vendors to come together and give a single presentation. So we had competitors actually working together in harmony to help advance the cause, and getting them all together. I gave them all tie-dye shirts as a thank you. So that's what it is. And Mark Rushton, who asked about 2020 or Bits by Bay. Well, 2020, no, that came in past, but even 2021, I tried to have it next year, and the venue is still not ready to book reservations for May next year, which is a scary thought. So we're still in the void locally from having that conference, but I look forward to having it again when I can. It's always a fun part of my life is to produce that.
And a fun part of everybody's life to attend it. It's got to be one of the top events I've attended, and I look forward to it.
We'll do it
Please
again.
bring
I
it
promise
back.
you. Yes.
Please bring it back. So, Peter, thank you again for this conversation. This has been very interesting. We're all living in this new normal, and I don't think there's any such thing as a new normal that will not evolve going forward. We probably all know that about our lives, and certainly broadcasters know that as well. So I hope we've helped inform a little bit about what broadcasters are facing in terms of moving from conventional legacy playout into cloud-based playout, where we seem to think the whole world is going. And if TAG can help you in your journey, please by all means contact us. You can get a free demo of our product, play with it yourself, and see what it's all about and learn what this new domain is all about. Peter, any wrapping comments you'd like to make?
This has been great. Thank you. And it's great to see so many of you here. And I'll just give a goodbye with all my 70s friends here. So thank you all.
That's really brilliant.
This is what a Zoom call should look like, right?
Absolutely. Thank you all very much, attendees.
Thank you.
Thank you, Dana and Cindy, who take care of us and enable us to do this. Otherwise, this would be a complete technical disaster. Thank you all.
Thanks, Cindy. Thanks, Paul.